How do we solve an equation in which multiple logarithm expressions appear? Well, we know how to solve an equation in which one logarithm expression appears, and provided the logs all have the same base, we know how to combine logarithm expressions. So, if we want to solve an equation that involves several logarithms with the same base, well, first, we'll use the log rules to combine all the logarithms, and then we'll rewrite our equation in exponential form. Now, each of those steps is a little bit more involved than it sounds if I just say it. But let's see how this comes together. Suppose we want to solve this equation. 2 times the log base 2 of x plus 2 plus 1 equals the log base 2 of x plus 5 plus 3. Now, in order to be able to combine all of the logs, we're going to want all of the logs on the same side of the equation. And in order to be able to rewrite in exponential form, we're going to want all of the numbers on the same side of the equation. So let's start with that. We'll start by subtracting log base 2 of x plus 5 on both sides, and we'll also subtract 1 on both sides. That'll give us 2 log 2 of x plus 2 minus log 2 of x plus 5 equals 2. Now we combine all these logs on the left, first dealing with the multiplication, and then dealing with the subtraction. So that's step 1 finished. All of our logs are combined into a single logarithm. Now, one thing to be alert for, notice that x plus 2 squared is always either positive or 0, even though x plus 2 might be negative. This step where we combine the logs may introduce extraneous solutions. The log rules only apply when the argument of the original logs was actually a positive number. So we'll need to check at the end. Now we rewrite our equation in exponential form. So the base is 2. The right-hand side becomes an exponent. Okay, now this is an equation that we know how to solve. This is a rational equation, so our next step also has the potential to introduce extraneous solutions. At our next step, we note x can't be negative 5, and then we can multiply both sides by x plus 5. Okay, so now this is going to be a polynomial equation. In order to solve this, we first need to multiply out and get all the terms on one side. So let's see. On the left, we'll have x squared plus 4x plus 4. On the right, 2 squared is 4. So we'll have 4x plus 20. Then we'll subtract the 4x on both sides, subtract the 20 on both sides, and we have x squared minus 16 equals 0. There are lots of ways we could solve that. I think the easiest one is x squared is 16, so x is plus or minus the square root 16, or plus or minus 4. Let's look back at the original equation. Our original equation was 2 log base 2 of x plus 2 plus 1 equals log base 2 of x plus 5 plus 3. If we plug in x equals -4, we get 2 times the log base 2 of -2 plus 1. It's log base 2 of 1 plus 3. Notice that we can't take the log of -2, so that was an extraneous solution. Something was undefined. What about 4? For x equals 4, we have 2 times the log base 2 of 6 plus 1 equals the log base 2 of 9 plus 3. Now, 6 and 9 don't have nice logs base 2, but we can check on our calculator. So 2 times, this calculator doesn't have the log in any base, so I'm going to have to say log 6 in another base divided by log 2 plus 1. So that's my left-hand side. For my right-hand side, I'll say log 9 divided by log 2 plus 3. And we see that those are exactly the same number. So that one worked. So x equals 4 is the only solution.